Okay, this is problem 3 for homework 4. I believe most of you have go through this, and I'm gonna demonstrate it by using MATLAB to see how does the zero changes for certain loop function may affect the total unit step output of the whole system. Okay, and this is a previously solution I write for this problem, and there might be some mistakes in this, and the main method are the same, so you're gonna try to figure out how to plot this in MATLAB and how to make it your plot more tidy by using some certain functions. So first we just clear the workspace, clear the screen, set the transfer functions parameter as s, set the tall initialized by 0, and this is a loop function given. This is the gain is 5440. The zeros are tall, and you can see this is a second order system with an s and with a pole as origin and other two poles on the left plane. As I said, this is a loop function, so let's use this method to make it a transfer function. I believe you all know how to do this, and we just skip this. After creating the transfer function, let's create the time array for this unit step output. Okay, in this case, I set the time start at 0 and end as 1 with a time interval of 10 to the minus 4. Okay, after setting the time arrays, we start to plot the step response of the transfer function. You can see I use step functions. This is step using transfer function g. In time array, the output is named as y0. Okay, so let's plot time to y0. This is the result. As you can see, it's understandable because originally I said it's a second order system, and it's supposed to have oscillations, right? Because there are poles and zeros here. It's a second order system. Okay, so as asked in the problem, we are asked to see when the zeros change for a certain loop transfer function, what will the percentage overshoot, rise time, and settling time change for the step response. Okay, let's see. First, the percentage overshoot. So how do we find the percentage overshoot for this certain figure? We can see that obviously it's here, but how do we find this? In here I use find peaks functions. It helps you to identify the peaks, the highest peaks of a step response on any figures, any arrays, any vectors. You can see there are two outputs. The first output is the overshot value, which is the peak value of this. This is about 1.3, this is about 1.1 or maybe. And the time overshoot, the second parameter output, is a corresponding time, it's corresponding x coordinates of this peak value. This one might be 0.25, somehow like that. Okay, and then as we all know, this find peaks is used for finding peaks, but there are many peaks in an oscillation figure. We only need the first one because it has the highest overshoot, right? So we use the first value of this array, name it as same as overshoot value, and its corresponding time. Okay, also the first one, and then we can calculate the percentage overshoot by using the differences between the overshoot value to the final stable value and divided by the final stable value times 100 because we need to get a percentage, right? Then we plot this. You can see that here I plot a red right circle at certain time where time is equals to this peak time and the value is this peak value. So I just write a red circle here in order to notice that this is a percentage overshoot point. And then I get a text here in order to illustrate what is this red circle means, because later we need to mark out the rise time or the stable time. We all need to give it an explanation for this label. And again, the x coordinates, the y coordinates, and what the tags are going to use here. There are two tiny points here are different from what you may saw initially. The first is that you can see a plus 100 here. So that this x coordinates is different from this point. It's slightly moving right. So why does this? I mean, I was gonna explain it later, but you can start to think about why I make it a little bit right. And another thing is that you can see this is a result. I got a backslash here because I need to transfer the meaning of underlines. If you have studied C or C++ or any similar computer science languages, you know that this is a transfer meaning of the underlines. And there's another function here. It's called number to string, because originally when we got the percentage overshoot, it is calculated by certain values. So its type is somehow like an integer or a double. So we need to change this into a string because we need to show it in text. And finally, we got a percentage symbol here. And this is the thing we got for here. Okay, this is a percentage overshoot. It's comparably simple as long as we know the find peaks function. Now we need to find the rise time. Let's consider what is the rise time of a certain step response. It's the first time it reaches the stable value, right? Okay, so we need to find out all the stable values of this step response, all the stable values and its corresponding time, right? And the first corresponding time is a rise time. You can see that I first set an arrow here, and then I find all the values in y0, which in the region of the stable value minus arrow to the stable value plus arrow. So it's a range between the minus arrow and plus arrow. Why do I do that? Well, MATLAB is it's a numerical tools. Although you can see it's a curve here, but actually there every tiny points that formed by your step. Like you can see, when you set the time array, there's a step of 10 to the minus 4. So these are many tiny points. Every distance in x coordinates between these 2 points is 10 to the minus 4. So if we don't set these arrows for this point, which you may apparently think as 1, it may be 0.99999, and the next point, since they're not continuous, they're discrete, the next point might be 1.00001. So if you ask MATLAB to find the exactly 1, it will just skip these 2 points because they're not exactly 1. So that's why we set an arrow here. I believe if you hate using arrows, or because if you think this expression is a little bit platitude, you may need to minimize your step in order to get a exactly 1, but I do recommend you to set arrows here to help you find these two points. And the following are similar. You just take the first of this array, its corresponding time, plot it, again right circle with the corresponding text. Okay, number to string again. So it's understandable for the rise time. Okay, the next is a settling time. You can just ignore what I write here because it's wrong. I just tell you that's wrong. But the thing is, you need to find out the method of searching for settling time, or you can see a settling point for this step response. It's a little bit tricky compared to the first two, because for the first two you can just find something within certain requirement and just take the first one of it. But for settling time, since you don't know after how many oscillations the step response has reached settling time, so you can't just take the first of it or take the second of it or the third of it. So you need to find another method to solve this problem. Well, here I just offer you one method. I can assure you that this is not the simplest and most convenient method, but it do works. You can just try to consider other method that may apply in this, but let me just tell you one, okay? So this method based on finding peaks, right? We all know that there's this function find peaks can return you two parameters, the y value and the x and its corresponding x value. So if we find all the peaks in the step response, and moreover we need to find all the bottoms of this figure just by inverse the original function and find peaks again, right? You can just find the corresponding x coordinates and find the y original coordinates, right? So you understand that. So in a settling time, for example, 2% above or lower the stable value, then you need to find out a peak that just within this range. What I mean just in this range is that the former points, the former peaks are not in this range, but this peak are just in this range. Okay, for example, in this figure, this one is obviously like 1.1 or 1.03, but this point might be 0.99. So this point is within the range, but this point is not within the range. Okay, so when we find this point, we just focus on the region between this point and its former peaks, as we all know that after reaching to this point, the following values of the step response is always within the region, because the amplitude of the oscillation is decreasing. So the stabilizing point must be between these two regions. You just need to find out the corresponding 1.02 or 0.98 in this region. Then you can find out when is the first settling time of this transfer function, right? So that's just a basic method. You can develop other methods in order to find the settling time, but like the others are the same. For example, plot or text, these are the same. But the point is how to find out a certain points of settling time. And afterwards, you just change the tall, rewrite the loop function, transfer function, and do this again. You can get another one. You can notice that if you use the same code as before, you will get a very messy figure, because all this text are gathered together if the oscillations are not very fierce. Okay, so now you can see why I add a plus 100 here, because I don't want this r, this rise time, or this percentage p are just on the right circle. I want to move it a little bit right in order to show you that, hey, I draw a right circle here. Okay, and the right one is this explanation of this label. Okay, now if you want to make this not feel that messy, you can just move the rise time, this text, a little bit left or a little bit up. Okay, a little bit down. It's on your choice, but you can change the x coordinates and y coordinates of this text in order to make it in a certain position, which make the figure much more pretty. You can do it by trying again, but I mean, that's a method how to make your figure more pretty, more tidy, rather than just using one same code. Okay, that's the following are just changing the talls, plot it again. You can see this will become so messy that you can barely recognize what is writing here, what is the value of this. So afterwards, you can just write the zero and poles plot of this and give your solution on this problem. Okay, so that's how to solve problem 3 for homework 4.